Okay, perfect. So I'm Edgar Nandayapa. I am a data steward here at Helmholtz Center in Berlin. And we have been developing some solutions to make it easier for colleagues to adopt NOMAD and benefit from everything that NOMAD can do for us. So I'm going to give you a quick summary of what we have developed, and then I will show you. And then we will continue later on the other room so that you guys can practice and actually use all these tools I'm about to show you. Yeah, so we want to motivate scientists to use NOMAD. This has been a whole process because especially for postdocs and for PhD students who have been working for some time, they already come with some sort of workflow that is sometimes complicated to change and to modify it to something else. So we have this idea that we need to make it extra easy and comfortable for them to move on to NOMAD. Otherwise, it's probably not so worth it for them because they already have something that works. Yeah, so we want to make their lives easier. We want to allow them to upload data in an easy way. We want to give them tools so that they can visualize and analyze the data. And also something very important lately is to be able to share the data, because sometimes all these results belong to a project, and it's better if all the people involved know what's going on with the work of the others. So in the future, we want to make everything automatized. We have been working a little bit with this, especially with newer equipment. We are asking now that they add a NOMAD button so that people can put their credentials and they can immediately upload their data after they have measured something. We are moving there. I don't have any examples yet because the equipment has not been delivered, but in principle, everything should be working for this particular equipment. So some of the previous colleagues have shown how to add data onto NOMAD. And I think the example from Aaron was quite nice because you probably saw how detailed and refined you can do all the process. But how many of you can remember what he did? And if you can replicate it, it's quite hard. So for a while, we were working with my lab colleagues to show them how the process was being done. One of my colleagues here prepared a very detailed guide on how to add all the batches and the changes, and it was quite comprehensive. And people had a guide that they could follow step by step so that they didn't have to ask us. But still, every week for every batch they did, they would come back and ask us for help because they got lost and it's too complicated. And I think once you get used to the NOMAD way, it's really not that bad. But yeah, most people don't have the patience or the time to really learn how to do it. So we came up with the idea of the Excel files, which the previous colleagues from KIT already show you. We have moved a little bit from the version they showed onto something else. So now we have colors, for example, as you can see here. So that it's easier to see which process you are working on in that moment. And once we introduce the Excel file, now our colleagues, our lab colleagues, are able to work by themselves, and we are getting a lot of data uploaded. I think it's not the ideal case yet, but compared to the previous time, now we actually have plenty of people who are constantly adding data onto Nomad, and that's pretty much what we want. So part of our focus in the last few months have been to develop apps that make our lives easier as admins and the lives of our colleagues also easier. So I call them the 3 pillars. So the first one is admin apps that only us, the data stewards, use. So for instance, we have here a spreadsheet creator. I will show you exactly how this works in a little bit. Also, we have some way of visualizing the data that people have been uploading, so we know how we are moving or how nicely our colleagues are adopting Nomad onto their normal workflow. And also, for example, I will show you how we use these apps to manage groups. So this is probably a good time to remind you to go onto Discord, and if you want to be part of the demonstration later, please share your email address in the Discord group. Solar Energy, I think it's called.
They can just email to you, but I think the point is that they need to have a normal account first, right?
Yeah. Yeah, well, and if you go there, you can find my contact, and then you can send me your email address. Because otherwise, well, we are creating groups, so it's a little bit more controlled, more easy to manage. So yeah, please send me your email address, so I add you into a group, and then you can have a test on these apps. Another pillar, it's the API-based apps. So the idea is that people are spending a lot of time filling this, the Excel files, and then the measurement files. And although Nomad gives you a lot of visualization options, scientists normally want to do something extra. So we have been trying to collect all of these extras and making them into apps. So I will show you also how this works after these slides. And also, in order to motivate our colleagues to start using Nomad, even if they don't have anything to do with it, or if their process is too complicated for Nomad, we have been trying to create different apps, like calculators for planning and for analysis of data that is not necessarily Nomad, so that people start feeling more comfortable and they start using Nomad, and they start seeing the benefits of putting their data there at one moment. So this was a very short presentation with slides. I will proceed to show you some details. If you want to follow along, you can log into this nomad-HZB-SE. You can access our Oasis. And also, this is the link for the Discord chat, so you guys can communicate with us.
So this is the time now where people actually get to do hands-on?
No, like here, like now I will give a very brief overview of all the apps we have developed, or some of them. And then later, you guys will be able to have access to some data to play around, and also to use the apps if you want. So moving on to the next part.
So I can share the link of the deployment in the channel, right?
Yeah. Or you're asking me if I did, or if
I should do it.
Sure, yeah, why not? This is a link I can share with you guys. It's like a simplified guide on how to reach different points, different interesting points I'm about to show you. This I can share in the Discord group. So this is how Nomad looks. Once you are part of the group, you're going to be able to go to explore, and then voila. And then you will have here many different apps. I have opened some of them already, so it's a bit easier for me to keep track. So this is one of the first one. Is quite simple but super useful. You can visualize here the different groups that have been developed, that have been created. All of them are from Helmholtz Center in Berlin. And then we have different buttons to add and remove members or create and delete groups. It's super useful because now you don't have to remember any specific codes. You just click buttons. We also have a different app to visualize how much usage Nomad is having. So, for example, here you can see that this MMB, for example, is a project. So they have been doing quite a bit of work. And also we can see who is uploading and how much. Going on to the Excel part, similar to the app that our colleagues showed, here we have some templates from the stuff that colleagues in the past have asked us for. We created some templates. So, for example, if you want to do triple tandem cells, you can apply. Yeah, so we have some templates. And then, like, I chose this one because it has a lot of processes. It's a triple tandem, so they are making 3 solar cells in one. And sometimes, for example, when you're doing perovskite, you need anti-solvent. And you can very easily select here if you want more or less solvents or the solutes. And also, if you need specific steps, you can add or remove. Or if you don't want, if you're doing a similar process, but you don't want this part, for example, you just remove it. And that's it. Now you can generate the Excel file. You can also select if you want a row of example values, which is useful because sometimes parameters can be a bit cryptic. So now you know if you need to write a word or a number, which I think is the best use for this. So here I can show you how this Excel file looks. So first, there's some experimental info. All of the batches have this. And then you have the first process you selected. In this case, as UV ozone cleaning, and then so on. You go with all the different options. I find it nice now with the colors that it's easier to know if you moved from one process to the other. Because as you can see, it's probably hundreds of columns. So the very first time that people fill this up, they are very angry, but afterwards they get happier. Also, one of the advantages I see from the Excel file is that you can do it the first time, and then when you do a different experiment, you just have to change 1 or 2 columns, and then you pretty much use the same sample again, the same file. So we have really seen an increment in usage after giving this option of the Excel file. Moving forward, maybe I can. Okay, so something that it was kind of shown in the previous presentation, but it was not really explained, is that once you measure something, a sample, you have a file, but the program doesn't have a way of knowing how this file is connected to a sample. So you have to rename the files in a certain way so that Nomad knows where to put the sample. And for that reason, we created this Nomad file uploader. So the normal process is that you go into here, for example, and now you have to rename this file so that it has the name of your Nomad ID should be shown in the file name. And this is quite a bit of a process. Like if you're doing it by hand and you measure 20 times, now you have to rename 20 samples pretty much by hand. So for that reason, we created this uploader app. So now it's very easy to come here. And let's see, maybe doesn't matter. Yeah, well, this one, let's say, or both. So that's also the beauty of this thing, that you can upload anything. If you have a recipe on a PDF file, you can upload it to a specific sample. So here you select what you are doing into which sample. And sometimes, for example, this is let's say a JV measurement, which is not a PL measurement, but let's say it's a JV measurement. Here you can select if it's a JV measurement. If the file has JV on the name, it adds it automatically. So you don't have to do this by hand. And this HY, for some reason, this is the default code. So any file that doesn't have a parser will have HY. So once you are happy, you can press upload and process data. I'm not going to press it now because then it's going to upload it, and we don't want to mess with my colleagues' data. So yeah, this is another different app. Okay, and this is another app that we created not too long ago. It's a design of experiments. I don't know if you've heard of that. Like I studied physics and did a lot of lab work, but never heard of this. For data scientists, I think it's more common. So you use a specific algorithm, which in this case is the Latin hypercube. And the idea is that you can plan an experiment in a way that you use all of the experimental space in the most efficient way. So the idea is that after you go through this process, you can apply algorithms like Bayesian optimization or something like that to obtain results faster with less experiments. So just to give you an idea here, for inkjet printing, we can do like speed, for example. And let's say that the machine can move from 1 to 5 meters per second. And we can do steps of 0, 0, 1, whatever that means. And yeah, once you are happy with the variables you have selected, you can generate samples. And here you can decide how many substrates you're going to do. For example, if you're doing 16, maybe you can do here 8. So at least you have two substrates per change. And then you generate samples. And now you can go to the lab and test this. And there are different ways of visualizing this stuff. If you are into the data science of it. It gives you a quicker idea of how good you are using the experimental space of this thing. You can also save it onto a text file, so you go to the lab and try this. A different app, for example, for JV analysis, you can filter your data, load it, and similar to what other colleagues were showing, on the Excel file there is this column called variation. So this is an easy way of knowing what change you did in this experiment. This variation column is shown here. These are the values shown here. You already get some summary of the data you measure, so a global mean of the PCE, and also what was the best sample, the worst sample, and then the best cell for each substrate. I don't know if you guys are familiar with solar cells. If not, sorry, it's a lot of bubble. But anyway, like you set your variations, you confirm the variables. Now we have some predetermined filters for your data, as the previous colleagues were saying. You don't want to go to the boss and show them all the shunted cells. So you apply the filter. Here it tells you how many samples were removed in total and why. So all these cells were shunted because the fill factor is less than 24%. So now you can plot stuff. And this is quite straightforward and simple. Here you have your plots. We have tried to make sure that all the plots are with Plotly because it's quite easy to turn data on and off, which for some reason is not working now. But yeah, now you can save all this information. You get an Excel file with all the box plot information if you want to do it on your own in Origin or something. Or also the images are saved automatically for you, so you put them in a PowerPoint. And going on to the other stuff, for example, this thing is to analyze SEM images. If you play around with these bars, you will at one point get a very good result. So this is one of the calculators that we will add in the future, because now we don't support the SEM images because they occupy a lot of space and we don't have too much space on the server. But once we have more space, we will add this onto the core API apps. Also, for example, I have a colleague working with solvents, and we work together to create a Hansen parameter calculator. If this doesn't mean anything to you, it doesn't matter. I just wanted to show you that here some calculations are done, you get the results. And now you have a visualization of how your solvents look when you combine them, which is the green, and what you are trying to reach, which is the red. So now you can go into the lab with a little bit more focus on what you wanted to do. This is related in a way, like you can select two different variables or parameters in a database. So this is an existing database that you can get from the internet with solvent parameters. And now you can visualize them in different ways with colors and so on. So if you need to create a specific type of solution and you need certain values, you can maybe go here and see which solvent would be the best for your purposes. And this was quite recent. I thought I had loaded some data already, but let's see. So this is just to visualize XRD measurements in a specific way. Let me see if I find something quick here. So once you load this data, the program already finds peaks. You can select if you want to see them in a plot together with the others. You have a list of the peaks. And here at the bottom, you have all the plots combined. Maybe this is not what you want. Maybe you want them separated, so you can separate them. And now this plot is ready to discuss with your boss. So as I was mentioning, this is just a quick overview of some of the apps we have developed for colleagues. And yeah, now for the hands-on experience, you guys can play with many of these apps. And yeah, if you have any questions, please let me know.